Hello, and welcome to Grade 3, Unit 4 Math Overview. During this time, you're going to want your Math Overview note sheet and you're going to want your notebook and something to write with. Feel free to pause the video at any time, take some good notes. Good luck. Here we go. We're going to start with the note sheets. So you should have this sheet out in front of you, and we're going to go slowly through each of the sections and add a little bit more that this unit needs. So on that added portions, make sure you take some good notes. All right, the first part we're going to talk about are parts of a fraction. A fraction is just a part of a whole number. So maybe we have like a whole pie. But we don't have the whole pie. We didn't eat the whole pie, or the whole pie wasn't eaten at a family function, only part of it was. Then we would have had a fraction amount. So the top is called the numerator. The top is how many parts you maybe had or ate or used. And the bottom is the denominator. That's how many whole parts your object was broken into. So in this circle, we can see that we had 4 parts to make that whole. Now, did we use all 4 parts? No, we only used 3 of them. So that's why the top is how much we used. The bottom is how many total parts we had to make the whole. We can draw it as a bar graph. We can also see it on a number line, where we break from whole numbers like 0 to 1, and we break them apart into smaller portions. The next part is called a unit fraction. The word unit means one piece. So a unit fraction is a fraction whose numerator is 1 and whose denominator is the whole number. Any fraction can be written as a sum of unit fractions. So maybe we have one piece out of the whole of 4. That would be the unit fraction of any drawing out of 4. So let's take a look at our example here. We see 4 equal parts that this circle is broken into. So the unit, the one piece of it, is going to be 1 on top and 4 on the bottom because we broke that circle into 4 parts. The unit is only one piece of it. Sum means addition problem. So we want the sum of a unit fraction. And if we're looking at this example, we're going to do of the shaded part, the part in purple. So we're going to do 1/4 because that's our unit fraction. And we're going to add that together as many times as we see shaded. So we see it shaded 3 different times. So we're going to do 1/4 plus 1/4 plus 1/4. Let's make that plus sign bigger. And that would be our sum of the unit fraction. That just shows how we got to our total answer. Now, sometimes we're going to see it as a multiplication problem. Product means multiplication problem. And it says of a unit fraction. So if we look back at this example, our unit fraction is 1/4. And we're going to times this now by the whole number of how many times. So we know that multiplication is just repeated addition. So how many times did we add our unit fractions? 3 times. Or you can see we have 3 pieces of our 1/4. So if we wanted to write it as a product of a whole number, it's going to be 3 times 1/4 or 1/4 times 3. Remember, the commutative property told us that we do not need to worry about the order for that. Usually a good rule of thumb is to write it the way the directions were written. The next part we're going to tackle is fractions on a number line. Notice you usually will have really big lines where the whole numbers are. And the whole numbers are big written. And then you might have it broken into parts. If we count each of these bumps, or frog hops, I like to call them, we would find that we have 4 parts between 0 and 1. So our denominator, bottom number, is going to be 4. Each time we have one of these little slashes, our numerator gets bigger by 1 amount. Now, if we wanted to write a fraction of our whole here, we could have written it as 4 over 4. Because if I have a pie and I have all 4 pieces out of the 4 given, I have the whole pie. All right, let's take a look at some examples here. We have some missing numbers where the boxes are. If I have 0 and I go to 1, I can see that they are broken into 1, 2, 3, 4, 5 parts. That's why they're using a denominator of 5. So if I have 1/5, my next one's going to be, good, 2/5. And then I will have 3/5, and then we're missing 4/5. And to get to the whole, it would be 5/5. The next one here is broken into 6 parts. So we're missing the 3/6 and the 5/6. The next one's broken into 8 parts. So we're missing the 3/8 and the 5/8. And the last one's broken into tenths. So we're missing the 3/10 and the 6/10 and the 9/10. Now, when we have number lines, and if we're putting them together correctly, you will have an even amount of space between each of your marks. So if you are creating your own number line, you might want to use a ruler, measure the space between the 0 and the 1, or whichever whole numbers you might be trying to get between, and then figure out how much space needs to be divided in order to get them evenly spaced apart. Now, when you have multiple ones like this, we can start doing a comparison. Like, what is equivalent to 3/6? If we look up and down the row, anything that is at the exact same tick mark, because we should have made them exactly the same spots away, would be equivalent. So 3/6 is equivalent to 4/8 and equivalent to 5/10, which makes sense because all of those are a half. How to read a ruler. Now, a ruler is also broken into wholes and parts, or fraction amounts. If we're working on inches, your big long lines are your whole amounts. Your next biggest lines are breaking into the half portions between your whole numbers. And then you'll have a slightly smaller tick mark. Those ones are your 1/4 areas. So if we had 1/4, we would have 2/4, and right here would become 3/4. And then we have even smaller tick marks between each of those, and those are all in 1/16. So we would have 1/16, 2/16, 3/16, 4/16, 5/16, all the way till we get to the whole number of 16/16. Now that is for inches. The same thing can be true if we're working on centimeters, but you'll notice that in centimeters, there is not 16 tick marks between each of your marks. And it's important to count how many you have. Comparing fractions is our next type of topic to talk about. The first one is when we have the same denominator, the bottom number. If our object is broken into the same amount of pieces, then we want the one that has the bigger numerator. Now, I like to always call this kind of Pac-Man because usually you have a circle, and sometimes I like to even draw my little Pac-Man eyeball on. And Pac-Man likes to eat the bigger numbers. If you've ever used Dreambox, you'll hear it as Ellie the alligator likes her scrumptious numbers. Scrumptious. Um, so we know that this symbol right here would be called less than. 1/4 is less than 3/4. If it has the same numerator, top number, but not the same denominator, then we want the one with the smaller denominator because that means it was broken into less pieces, which means the pieces are bigger that you're getting. So if I broke it into 4 pieces, notice how much bigger these two are than when I broke it into 6 pieces. The pieces just got smaller because our object to begin with stayed the same. This symbol right here would be called greater than. 2/4 is greater than 2/6. If we do not have any type of commonality in our numerators and our denominators, we could use some that are looking at just benchmarks, like maybe a half. If I have 3 out of 8, half of 3 or half of 8 would be 4 out of 8. So I know that this one is slightly smaller than a half. On the other side, if I have 6 on the bottom, half of 6 is 3. So 4 is bigger than half. So I then would know, just by using some mathematical reasoning, that 4/6 is greater than 3/8. So we can look at equivalence based on maybe drawing some shapes, always making sure your shapes are the same size, using a ruler to create equivalent parts that you're breaking it into. I'll show you one more method that can get you those kind of fractions. So in this case, we're going to look, we have the same numerators, so we have the same amount of pieces, but we have different amounts that our whole is broken into. We're broken into 5 pieces or 7 pieces. I'm going to want the one that has 5 pieces. So this is going to be a greater than symbol. On our next example, we have common denominators. So we're going to look at the numerators. If I have 3 pieces out of 6 or 4 pieces out of 6, I'm going to want that 4 out of 6. So that is less than. Now, again, sometimes when we look at them, they're really hard to determine which one is the same. So we can find equivalent fractions with the same bottom number. So I can start looking at multiples of 5. Can 5 become 8? No. 5 times 2 is 10. 8 can't become 10. 15. 8 can't become 15. 20. 8 can't become 20. 25. Nope. 30. Nope. 35. Nope. 40. Oh, yes, 8 can become 40. So I'm going to multiply the 5 times 8, and what I do to a bottom, I do to a top. This will create an equivalent fraction. So 4 times 8 is 32, and 5 times 8 is 40. So we just created an equivalent fraction that is equal to 4/5. We're going to do the same to the other side. We want to make this bottom number 40. So we're going to do 8 times 5. And what we do to the bottom, we do to the top to create equivalent fractions. So we're going to get 30/40. Now we can compare these because now I have a common denominator. They both have 40 on the bottom. I had 32 on top and 30 on top. I know that 32 is bigger than 30. Now I know this right here is a new skill. Write this example down. Rewatch this video portion if you need to really try to start getting an understanding of how to make equivalent fractions. And do some extra practice. Moving on to our next concept, it's line plots. Line plots use this number line that is broken into parts. Sometimes it uses wholes and parts. Sometimes it just uses whole numbers. It all depends. And then we have X's or dots that will mark um, each of our piece of data. So let's take a look at some features in a line plot. The first feature you're going to see is this right here, amount Jane ran each day. This is called the title. The title needs to be displayed towards the top to help you understand what this number line is talking about. Again, each of these X's represents one piece of data. So that would be how much she ran each day. So she ran 2 miles. She ran in one day. She ran 2 1/3 miles in a different day, 2 1/3 miles in another day. And that's why we have 2 X's, because 2 different days got that same data value. The next part are these numbers below that number line. That is the values that could have been earned. You want to keep these in a consistent interval. So notice they marked these in thirds. 2, 2 1/3, 2 2/3, 3, 3 1/3, 3 2/3, 4. Even though some of the data values do not have any data in them, they still need to be there to show our equal piece amounts. This bottom part here is called a label. We need a label down at the bottom to tell us what those numbers mean. In this case, they mean miles. And the last thing to point out is an outlier. An outlier is a piece of data that doesn't really make sense. It's really far away from majority of the rest of the data. And that outlier can really change our results. So there's times when we just take that outlier out to really give the best idea as to what the average amount Jane ran each day is. Time is another thing in this unit. Hopefully, by this point in your math career, you have learned a little bit about clock reading. The top is 12 o'clock. We go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Each of these also can represent minutes, and there are 5 minutes between each of these whole numbers. So again, we have 5 parts between a whole. The long hand is the minute hand, the short hand is the hour hand. Some new terms that you might need: quarter past. So if we broke our clock into 4 parts, we call 4 parts a quarter. So if I have only one piece of that quarter, I have quarter past the hour. Half past is going all the way to the half hour mark. And quarter to would be when I'm 15 minutes, to the hour to hand. So now we're going to look at how to write an example using this clock. So if I notice my hour hand is between the 11 and the 12, so that means it's after 11 o'clock and not quite 12 o'clock. The minute hand is on the 8. So if we count by fives, 5, 10, 15, 20, 25, 30, 35, that would be at 40 minutes. So we can write our time based on how many minutes to the hour and how many minutes from the hour we have. So your answer might look something like that. That I have 20 minutes to 12 o'clock or 40 minutes past 11 o'clock. So we have that past and the to. And we say how many minutes are past and how many minutes to. Elapsed time. This is a skill that takes a lot of extra practice. iExcel does a great job of giving extra practice. Dreambox can, Bottle. There's so many websites out there that can give you extra practice on elapsed time. Elapsed time is so important in math. Even as an adult, you'll see your parents, maybe they need to get you to an activity on time and they have to calculate how long does it take to get there, how much time ahead of time you need to be there, all that sort. And so they're constantly doing elapsed time to make sure that you leave on time for your activity. There are some different ways you can tackle this. You can tackle it with just looking at clocks and working your way around them. You could work on a T chart where you have your start time and you get to your end time and you're adding your hours and minutes into it. And then the number line kind of does the same thing. So if we start at 3:05, we got 1 hour at 4:05, another hour at 5:05, 5 minutes to 5:10, 10 minutes to 5:20, and another 10 minutes to 5:30. So our elapsed time is 2 hours and 25 minutes. We would start at 3:05 and end at 5:30. Now's the time to do some practice of these types of problems. Feel free to pause the video, try them out on your own, resume to see how you did. If you need extra help, rewatch the video. Otherwise, pay attention when we go through the answers. Welcome back. All right, let's take a look at example 1. Circle all that show the shaded fractions. So I can see it's broken into 4 parts. So I know I have 1/4, 1/4, 1/4. So C works. And if I add my 1/4 plus 2/4, I get 3/4 when I add my third part. So A and C. Taking a look at our clock, I notice I'm between the 11 and the 12. And my clock, my minute hand is not quite at the 8. It looks like it's maybe 1 minute before the 8. So the 8 would have been at 40. 1 minute before would be 39. So I know I went 39 minutes past 11 o'clock. So that would be letter C. And I have 21 more minutes until I get to 12 o'clock. And that would be A. So A and C are yes, the other 2 are no. Bob starts his homework at 6:30. He spends 35 minutes doing math, 40 minutes doing science. At what time does Bob finish his homework? So again, we can choose to do this in a T chart or a number line. Whoop, that number line got a little squiggly. We started at 6:30. If we add in our 30 minutes, we're at 7. We need 5 more minutes to get us to that 35 mark. So that'd be 7:05. And then we need 40 more minutes on top of that. We get to 7:45. Now, don't forget your label. In this case, we were talking about PM. We did not go into the AM range, so our answer is 7:45 PM. The time spent on homework, we can add the 35 and the 40 minutes together and get 75, or we can convert it into hours, which it would be 1 hour and 15 minutes. Our next portion down here, if we have 2 shelves, the wood shelf is 2/4, so they gave us a drawing. We can shade in the 2 out of the 4 for the wood, and we have 2 out of 8 for the metal, so we can shade in the 2 out of the 8 for the metal shelf, and we'll find out which shelf is bigger, and we found out it is the wood shelf. Our elapsed time, if we start at 8:15 and we go 35 minutes, we're going to end at 8:53 a.m. If we end at 4:20 and we back it up 55 minutes, we're going to start at 3:25 p.m. And if we start at 10:45 a.m., we go 2 hours and 25 minutes. We'll end at 1:10 p.m. Notice in this case, we went from a.m. and we converted over towards the p.m. Check out the skills plan in IXL for grade 3, unit 4. And feel free to work through the Math Activity Center of the lesson checks to help you prepare for this unit. Rewatch the video if you need to. Hopefully you took some good notes, and good luck.